Hi, this video is to give you some suggestions on how to use your engineering drawing to model the prosthetic upper arm. So we're going to be referring to the lower part of this drawing. The upper arm is the one with 4 holes. It's not the forearm. So this is this part of the drawing. So we're going to begin by just laying out a rectangle that's 25 millimeters wide, 185 millimeters long, and 4 millimeters thick. I want to note that I am just using the default dimensions. Your inspect design should differ. I'm not sure, but possibly even the orientation of these small holes for the 1/8 inch rod and rubber bands versus these for the joining of the joints and to the base. All of that may differ substantially on your inspect design. So let's start with this 185 by 25 by 4 millimeter rectangle. I'm going to make my height 4 millimeters, one dimension 25, and one at 185. Okay, 185 should fit on this work plane without adjustment. As before, we might want to make sure that we are in a flat view, as they call it, or orthographic projection to be more precise. I'm going to drop in a ruler exactly on a major grid line. Now, I think I'm going to want to set the end of this to 0. I want to 0 one end on my ruler, but then I want to switch to the midpoint and 0 the midpoint on my ruler, so that now with my ruler in the center of this rectangle, I can line up all of the midpoint of all of my holes to that midpoint there. Okay, so we'll start with one cylinder. I'm going to increase the number of sides to the maximum. Again, I want to avoid this polygon situation. I want to smooth that out. I'm going to make 2 of these that are 7 millimeters in diameter. These are going to be my larger holes from a 1/4 inch drill. Now, 1/4 inch is actually 6.35 millimeters. I could even go so far as to change my units to inches. But I actually want to increase the size of that hole somewhat, because when this 3D prints, things tend to print a little smaller than designed because of the way that 3D printing works, because of the melting plastic. So one of these 7 millimeter for 1/4 inch holes is going to be 10 millimeters from the end, right here. That's that dimension, and another one will be 170. So let's 0 this, center it first, and then one of these will be at 10 millimeters. That should be properly positioned. Now, if I use the hold Alt, I could also select and copy and paste that, but if I hold down the Alt button and drag, that's going to make a copy. And this one is at 170. So you see those 2 holes positioned now. Now I'm going to, I like to just drag another copy of this, hold the Alt key, drag another copy for making my my smaller holes. So these holes, these smaller holes, are 1/8 of an inch, which is equal to 3.175 millimeters. If we're going to similarly increase these, we might go as far as 4. I believe, well, I think we've had success in the past with a 3.5 millimeter hole being a pretty good press fit for. I think that an 1/8 inch axle will fit if we make these 3.5. So again, we're kind of winging it, but just basing this on past experience. 3.5 is going to be a tight press fit, but it should still work. Okay, so now we'll 0 that to center it, and place one at 50. This is just according to the design I'm working off of. Okay, I'm going to hold Alt. Let me just show that I can also select that and Control C, Control V. I can also copy and paste, and then sort of with that one already selected, I could place that at 130 millimeters from the end. So this dimension becomes 130. Okay, this dimension needs to be 0 to 0 it on the midpoint. And now we're going to see all those holes are properly placed. You might as well Control A, select everything, and Control G, group the solid with all of the holes. And that piece is done. I could close my ruler at this point. There's another step in here in the so there is another step in the instructions that says the end that needs to go near the base needs to have its corners rounded to make this clear with the base. Now they say 5 millimeters from each corner. You could get a little fancier here if you wanted to and put a true radius on this. I think what they're looking at is essentially just cutting the corner a little bit. I'll take this cut, rotate it to 45 degrees. I'll hold my Alt button to make another copy to drag down here if I can. Okay, just going to zoom in a good bit. And I mean, one option here is just to eyeball this. We should have, well, without the ruler, we don't really have the 5 millimeter references. So 1, 2, 3, 4, 5. That's 1, 2, 3, 4, 5. 1, 2, 3, 4. So I don't know. It's somewhat perhaps close enough. I could leave it up to you. You could definitely find ways to get quite a bit more precise. Maybe important to get a little more precise. Right now, I'm just going to guess that having a little more clearance is better than having too little. So I'll just move those in like so. Select all of this and group it. And there we've cut that piece off. Now at this point, we know we're going to need 2 of these pieces. We could duplicate this in Tinkercad, but it's just better practice to make copies in the slicing software, Kira, before printing. We can bring in one of these and make a copy of it in the slicing software. That's going to make sure we don't make mistakes like importing a model where, say if we duplicate this, one is accidentally elevated a little bit, causing a print fail. You know, this could work. It could be exported as 2, but it's just, if we make the copy in Kira, then we can move things around in Kira. If we bring this into Kira like so, we're just stuck with what we exported here. So I would just delete that, and we are done.